Today we are going to discuss a new chapter, Electrochemistry. I generally used to tell you the definition of any particular topic is there in its name itself. Similarly, the name Electrochemistry, it is made up of two terms, electro and chemistry. Electro means anywhere concerned with electrical energy, and chemistry, it is concerned with chemical energy. It means it is anywhere concerned with electrical and chemical energy. So, the branch of chemistry in which we discuss the interconversion of electrical and chemical energy means wherever the electrical energy convert into chemical energy and chemical energy convert into electrical energy, that particular branch of chemistry is known as electrochemistry. As I already told you, the name is defining itself. Electrochemistry means the branch of chemistry where we used to study the interconversion of electrical and chemical energy. Sometimes the electrical energy convert into chemical energy, and sometimes the chemical energy convert into electrical energy. Obviously, these the interconversion takes place there in several equipments. Here, as I have told you, electrical into chemical and chemical into electrical. It means we should have two equipments. What are these? There are some electrochemical cells, as the electrochemistry is there. Similarly, electrochemical cell means those cells which anywhere convert electrical into chemical or chemical into electrical energy. So these electrochemical cells are of two types. One, electrolytic cell, and another one, galvanic cell. Electrolytic cells are those cells in which electrical energy convert into chemical energy. Electrolytic means electrical energy convert into chemical energy, and the galvanic cells are those cells which convert the chemical energy into electrical energy. Means you can see that in general example, we are having so many kind of machines which run with batteries or any source of energy. Just like we are having wristwatch. In wristwatch, you can see that it required energy. There is a cell used in which the chemical energy convert into electrical energy. Similarly, the electrolysis process we studied there in a junior class, where we studied when electricity is passed in an electrolytic solution, it breaks down into its ion. That is anywhere concerned with electrical energy into chemical energy. In our homes nowadays we are using inverter. In those inverter, you can see that whenever the current is not there in system, you can see that electricity is used through the inverter. In inverter, that chemical energy is converting into electrical energy. Means the battery, whatever is used there in that inverter, that is galvanic cell. Right? So these are the electrochemical cells about which we will discuss deeply in later. Before that, we will discuss about some electrical conductors. Actually, we are talking about the electrical energy and the chemical energy. That's why we will have to understand what are the conductors. Here in this topic, we will discuss the conductors, which are two types, right? One, you already know, metallic conductors are there, and another type of conductor you will study. These are electrolytic conductors. Metallic conductor, you can see copper wire, right? Aluminium, silver. These are the metallic conductors. Means whenever we used to talk about the electrical conductors, these are of two types: metallic Another one, electrolytic. Right? Metallic, very simple, you can see. We are having copper, we are having silver, we are having aluminium, we are having any, just like iron. These metals, so many other metals are also there. We know that the metals are good conductor. These are the metallic conductor. Another type is electrolytic conductors. Electrolytic conductor means the solutions of polar compound, just like NaCl solution, KCl solution, HCl solution. Now the question is there, what are the electrolytic conductor? Firstly, electrolyte. Electrolyte means those compound which dissociate in their solution on passing current. Whenever they used to break down into ions, just like I have NaCl solution, right? We are having NaCl solution. We pass electric current on it through an external circuit, right? These are the electrodes, plus minus, right? It break down into what happened? NaCl break down into Na positive and Cl negative. In metals, we are having, just like if I will take example of aluminium, we know aluminium is having 13 electrons and its electronic configuration is 283. These 3 electrons are free electrons, right? What I am going to tell you, actually, what are responsible for carrying electricity in metals and what are responsible for carrying the current in electrolytic solution. In metals, as I told you, metals are having 3 electrons. In metallic conductor, the charge carriers are electrons. How can you say? Suppose that this is a metallic wire, right? This is a metallic wire in which the electrons are free and they used to move in different direction, in random motion, you can say, right? These are the electrons which are free electrons. As they connected with the electric circuit, whenever they face electric force, these electrons used to move in straight direction and they used to carry the charge. You know, electrons are charged particle. Each electron carry 1.6 into 10 raised to power minus 19 coulomb charge. These electrons are charge carrying in metallic conductors. While in an electrolytic conductor, these ions are charge carrier. Very important difference between metallic and electrolytic conductor. First, that the charge carrier in metallic conductor are 3 electrons, while in electrolytic solution the charge carriers are the ions. These are the charge carriers. Similarly, another difference between the metallic and electrolytic conductor, you have seen, whenever a current passes through a metallic wire, you can see there is no any change in that particular metal. Just like in a domestic system, you have seen domestic circuits, there are the copper wire is used for conduction of light. It never changes on passing current. Means there is no any change in metals after passing current through it. While whenever the electricity will pass by the electrolytic conductor, you will see they will completely change. There will be a chemical change. They will dissociate into their ions. Means there will be a chemical change after passing current, while there will not be any change in metallic conductor after passing current through it. Another most important difference between the metallic conductor and electrolytic conductor is the temperature. You know, whenever the temperature increases, whenever the temperature increases, the force between these ions will decrease. Means temperature will increase, the force between solute and solute, you can say, solute and solvent, you can say, or interionic force will decreases, and the conduction of electrolytic conductor will increase on increasing temperature. Most important fact. What? On increasing temperature, the conduction of electrolytic conductor will increase. Question can be there. Why? Because on increasing temperature, you can see the interaction between the solute-solute, or you can say solute-solvent, or you can say interionic forces, they will decrease and the conduction will increase. While on increasing temperature, the conduction of metallic conductor get decreased. Now the question is there, why? Because on increasing temperature, the resistance of that particular metallic wire increases, and on increasing resistance, the conduction get decreased. Right? The next topic what we will discuss, that is electrical conductance. Actually we are talking about the conduction, electrolytic conduction and metallic conduction. In same part we are going to discuss about the electrical conductance. Electrical conductance, what is this? Sir, it is simply electrical conductance is reciprocal of resistance. It is what? Reciprocal of resistance. Resistance is R, you all know. So what can I write it? RC equal to 1 upon R. R resistance is there, we all know. So conductance, if somebody will ask you what is electrical conductance, it is simply electrical conductance is reciprocal of resistance. Right? If somebody will ask you what is the unit, generally in these kind of quantities we need the unit of these kind of things. Unit of electrical conductance will be 1 upon ohm. You all knows the ohm is the unit of resistance. That's why it can also be written as ohm inverse 1, which is also written as Simon. Means the unit of electrical conductance, whether you can say ohm inverse or you can say Simon. In same sequence, we are having another topic, is specific conductance. Specific conductance. It's very important. Specific conductance is denoted with kappa. It is just like K, you can say, and called kappa. Right? What is this? Just like electrical conductance was reciprocal of resistance, similarly the specific conductance is reciprocal of, it is reciprocal of resistivity, rho. It is reciprocal of resistivity, and as I told you, it is denoted with kappa. So kappa will equal to 1 upon rho. We have studied about this rho in Ohm's law. Ohm's law tells us V equal to R equal to R is directly proportional to L. R is inversely proportional to cross section area, and that's why R is